All right, we talked in class today about 6.1 about relating lines to planes. Remember, by definition, a plane is a surface such that if any 2 points on the surface are connected by a line, all points of the line are also on the surface, which is really just a nice way of telling us that we have a flat surface that a line can sit on and not a round surface that a straw would go through, like poking a straw through an orange. So it's not going to go through because it's not round, it's flat, right? Flat. So visual concept of a plane is pretty basic there. So let me go to the second one. Our second slide was about coplanar versus non-coplanar. We looked at this picture in class and we noted that A, B, S, T, and V are coplanar points. Line AB and line ST, or segment AB and segment ST, are also coplanar. They sit on the same surface. But the moment that we introduced R or P into that mix, then we start having non-coplanar. R is out here, not on the plane. P is out here, not on plane M. That line RP that intersects plane M, that point where it intersects, maybe it'll pop up, maybe it won't. Please. All right, so the foot of a line is the point where the line intersects the plane. So that this point V is the foot of RP in plane M. So that idea of being more so about being able to read it than necessarily being able to use the word foot on a test or a quiz. Obviously, if you're asking me a question about a problem, you should say the word foot as we need it. All right. We also talked today about 4 ways to determine a plane. And I asked you to think about that determining a plane as though we're trying to set up a table or an emergency situation. So what's the minimum that you can use? And we talked about using posts or using points and planks, logs, or sawhorses as lines. So could we use just one post? No, because it would topple over, right? It's not going to work. Can you use 2 points? Well, you would get it set up, but it wouldn't be very stable. So no, 2 points do not determine a plane. 2 points determine one line, and a line isn't enough to support a plane. But if I had 3 points, like we have in this picture here, then I have enough to support my plane. So 3 points determine a plane. All right, today is not my technology day. All right, 3 points determine a plane. So let's go to step 2. And in step 2, we talked about a line and a point not on the line determine a plane. So if we had a line and a point, then we would be able to say that we had a plane. 2 intersecting lines determine a plane. 2 intersecting lines. So just the fact that those 2 lines cross means that they determine a plane. Plane may not always be in our picture, but they do in fact determine a plane. 2 parallel lines determine a plane. So 2 lines side by side determine a plane. So, lines and planes. If a line intersects a plane not containing it, then the intersection is exactly 1 point. So think of it in terms of a surface, right? Here's a plane, and a line intersects a plane means that it's going to go through it. And the only thing that can happen, no matter how I turn that line, right, is that it has exactly one point that touches the plane. So that no matter what happens, I end up with a point P as an intersection point. Now let's talk about if two planes intersect. If two planes intersect, their intersection is exactly one line. So where do they cross, right? Intersection. So if we take a horizontal plane and we extend it so that we can see where it crosses or intersects a vertical plane, we're going to find that that happens at a line, that intersection point is a line. This one right here. A chapter 1 reminder is that symbol with the upside down U is the symbol for an intersection. Whoa, lots of stuff turned on there. Chapter 1 reminder that the upside down U is the symbol for intersection. Told you today is not my technology day. So let's practice. I'm going to go ahead and clear all of these answers out of here. I suggest that you just take a second and give those problems a try. They're the same ones that are in your book, so if the screen's a little bit hard to see, go ahead and fill it out. Or grab your book and answer the questions there. But take a moment, pause the video, see what you can figure out, see how much you really do understand. Okay, hopefully you're coming back, and now we're going to go ahead and talk about it together and fill in some answers here. So that if plane M intersects plane N, the intersection of two planes is at a line, so we would say line AB. A, B, and V determine plane A, B, and V are all on plane M. So they determine plane M. Just those 3 points. We wouldn't need anything else that's on it. Name the foot of RS in M. So the point that's on RS at the spot where it intersects plane M is point P. Line AB and line RS determine plane N. Two lines determine a plane. Line AB and point blank determine plane N. You could have two possible answers here. You could say R and you could also say yes, S. R, or you might have said S. Either one is acceptable. Does W lie in plane N? No, it is not in plane N. Line AB and line blank determine plane M. Again, it depends on how you want to name it. There are quite a few options on naming this line. That goes back to chapter 1 skills, right? But line VW, WV, VP, PW, whichever one you want. H, ABV and blank are coplanar. You could say P, or you could say W. More than one answer there. ABV and blank are non-coplanar. So we need to pick one that's not on the plane, so we could pick either R or S. If R and S lie in plane N, what can be said about line RS? It is also in plane N. It's the very first thing that we talked about. Pretty sure you're confident in these. If you have questions, bring them in. Homework assignment was changed, section 6.1. You're going to do numbers 1 through 3, 7, and 8, and number 15, I believe it is. Calendar is accurate online, but not on your hard copy. Have a great night. I'll see you in the morning.